What if the deepest, most profound silence of outer space isn't silent at all? What if, beneath a fractured shell of ice, miles and miles thick, an ancient, dark ocean is trying to speak to us? Not with words, but with a rhythm, a pattern, an encrypted signal pulsing from the heart of a distant moon. Tonight, we are not just stargazing, we are embarking on a journey of the mind, a tranquil voyage to Jupiter's moon, Europa. We will drift through the velvet blackness, past the swirling storms of a gas giant, to listen closely to the whispers of its cosmic ocean. You will not need a telescope or a spaceship, only your imagination. Allow the sound of my voice to be your guide as we seek to understand the strange music coming from the deep. Prepare to relax, to let go of the day, and to float into a mystery as vast as the universe itself. Before we dive beneath the ice, let us orient ourselves in the grand tapestry of the cosmos. Picture our solar system, a delicate cosmic dance orchestrated by the sun's immense gravity. We travel outwards, past the rocky inner planets, past the great asteroid belt, to the realm of giants. Here, Jupiter reigns supreme. It is a world so large that all other planets in our solar system could fit inside it. It is a masterpiece of chaos and beauty, with clouds of ammonia and water swirling in belts of white, red, orange, brown, and yellow. And around this magnificent king of planets, a royal court of moons performs an endless, silent ballet. 4 of them are large enough to be worlds in their own right, discovered by Galileo Galilei 4 centuries ago. They are Io, the volcanic heart of fire; Ganymede, the largest moon in our solar system; Callisto, the ancient, cratered elder; and our destination, Europa. From a distance, Europa looks like a smooth porcelain sphere, cracked with fine, dark lines. It is a world of ice, shimmering in the faint sunlight that reaches it. For decades, scientists believed it was just that, a dead, frozen ball of rock and ice. But as our probes drew closer, they saw something that changed everything. The surface wasn't ancient and static. It was young, active. The cracks and ridges suggested that the icy shell was not solid to the core. They suggested that the surface was merely a crust, floating on something vast, liquid and hidden below. Let our journey begin in earnest. Imagine yourself suspended in the silent void, a traveler of consciousness. Earth is a distant blue marble behind you, its worries and noises fading into a single, peaceful point of light. Ahead, Jupiter grows, not as a point, but as a destination. It fills your view, a colossal globe of churning, hypnotic storms. The great red spot, a tempest larger than our entire planet, swirls with a silent, majestic fury. You feel a sense of profound scale, a humbling recognition of your place in this immense cosmic theater. You are small, yes, but you are also a part of this. You are stardust, awakened. As you drift closer, you begin to see Jupiter's family of moons, orbiting like loyal attendants. You glide past Io, its surface painted in hellish yellows and oranges by countless sulfur volcanoes. A world constantly turning itself inside out. You see Ganymede, a giant in its own right, with its own magnetic field, a world of dark, ancient terrain and younger, brighter grooves. But your focus is drawn to one moon in particular. It shines with a brilliant, white light, reflecting the distant sun. It looks serene, almost perfect. like a polished stone veined with intricate reddish-brown threads. This is Europa. As you approach, the silence of space seems to deepen, as if holding its breath. The chaotic beauty of Jupiter becomes a backdrop to this placid, icy sphere. It pulls you in, not with overwhelming gravity, but with an irresistible sense of mystery. You know that what you are seeing is only a mask, a beautiful frozen facade hiding one of an entire solar system's greatest secrets. The air grows still, the journey slows, and you prepare to explore the surface of this enigmatic world, a world that whispers of a hidden ocean and the possibility of life. This initial approach is a meditation on distance and perspective, a way to shed the weight of the terrestrial and embrace the quiet wonder of the interplanetary. It is the first step in unwrapping a cosmic gift, layer by beautiful layer. We now hover just above Europa's surface. The brilliant white is no longer uniform. It resolves into a vast, fractured landscape of ice. It is a world of breathtaking and alien geology. The surface is not smooth, but a mosaic of plains, ridges, and jumbled blocks of ice the size of cities. Imagine endless fields of frozen water, stretching to a horizon that curves away sharply, reminding you that you are on a small world. The sun is just a bright star in the black sky, casting long, stark shadows that accentuate the terrain. The silence here is absolute, a quiet so deep it feels like a physical presence. There are no winds to howl, no rivers to rush. There is only the slow, inexorable cracking of ice under tidal stress. The most striking features are the dark, reddish lines that crisscross the entire moon. These are the lineae. Some run straight for thousands of kilometers, like immense highways carved by a giant's hand. Others are curved and cycloidal, forming intricate patterns. Scientists believe these are cracks in the icy crust, where warmer, slushy ice or liquid water from below has welled up and frozen, stained by salts and minerals from the hidden ocean. It is as if the moon is showing its veins, hinting at the lifeblood flowing beneath. Then there are the regions known as chaos terrain. Here the ice sheet has been broken, tilted, and refrozen into a chaotic jumble. It looks as if vast rafts of ice have drifted and collided, like Arctic ice flows, on an unimaginable scale. These areas are believed to be places where the ocean below has melted the ice shell to its thinnest point, or perhaps even broken through entirely for a brief, steamy moment in the distant past. As you drift over this landscape, you feel a sense of profound history, a geological story told not in rock, but in water ice. Every crack is a sentence, every chaos region a chapter in the moon's long and dynamic life. You are an archaeologist of ice, reading the story of a world's hidden heart, written on its frozen skin. This is a place of cold, silent beauty, a testament to the powerful forces at play, even in the farthest, coldest reaches of our solar system. Our journey now takes us from observer to explorer. We must go deeper. We must pierce the veil of ice and descend into the hidden ocean. Let your mind become a vessel capable of phasing through the solid surface. We begin our descent. The first few meters are brittle, radiation-scarred ice, bombarded for eons by Jupiter's fierce magnetic field. The light from the distant sun begins to fade almost immediately, replaced by a deep, crystalline blue. As we sink further, The pressure builds. The ice is no longer brittle, but becomes plastic, flowing slowly like a glacier in hyperspeed. We are sinking through a shell that is estimated to be between 10 and 15 miles thick. Miles of solid frozen water above us. Imagine the sheer weight, the immense pressure. The journey downwards is a journey through time. The layers of ice hold a record of Europa's history, trapping particles from space, chemical traces from Jupiter, and perhaps even clues from the ocean below. We pass through layers of varying clarity and density, a geological column made of a single substance in different states. The blue light from above is now gone completely. We are in total, absolute darkness. There is no sound, but the groaning and shifting of the ice around us, a sound that travels not through air, but through the solid medium itself. It is a deep, resonant hum, the voice of the moon's tidal flexing. Jupiter's immense gravity pulls and squeezes Europa, creating friction and heat deep within its core and its ice shell. This tidal energy is what keeps the ocean below from freezing solid. It is the engine that drives this world. As we approach the bottom of the ice shell, the character of the ice changes again. It becomes warmer, softer. We might encounter vast subglacial lakes, pockets of meltwater trapped within the icy matrix, worlds within worlds. And then, after a long, slow descent through miles of darkness and pressure, we feel a change, a transition. The solid gives way to liquid. We have arrived. We have passed through the Great Wall of Ice and are now floating in the largest ocean in our solar system, an ocean hidden from the universe for billions of years. We are now suspended in an environment completely alien to human experience. We are in the subglacial ocean of Europa. The darkness is total, a blackness so complete that it feels tangible, a velvet blanket enveloping everything. There is no up or down, only the gentle, buoyant push of the water around us. The pressure here is immense, hundreds of times greater than at the deepest point in Earth's oceans. It is a pressure that would crush any submarine we have ever built. But in our journey of consciousness, we are immune. We are free to drift, to observe, to listen. The water is not empty. It is a chemical soup, rich in salts and minerals, leached from the rocky seafloor below. We can imagine the taste. Salty, perhaps metallic, laced with sulfates. These are the very ingredients that, on Earth, form the building blocks of life. The silence here is different from the silence of space. It is not an absence of sound, but a presence of deep, resonant quiet. The groaning of the ice shell above is now a distant, muffled thunder, the slow heartbeat of the moon. We might hear the hiss and crackle of cryogeysers, plumes of water vapor erupting from the seafloor or through cracks in the ice, a process that could send ocean material into space. But it is here, in this immense, dark, and pressurized place, that the concept of encrypted signals begins to take shape. The signals are not radio waves or laser beams. They are the subtle, rhythmic patterns hidden within the natural sounds of this world. Imagine the rhythmic tremor of a tidal bulge passing overhead, a predictable, periodic surge of energy through the water. Imagine the faint, percussive pops of minerals precipitating out of super-saturated water near a heat source. These are the natural rhythms of a geologically active ocean world. These are the planet's own vital signs. The encryption is not a code to be broken, but a complexity to be understood. It is the difference between random noise and a structured, albeit natural, pattern. It is in these patterns that scientists are looking for clues, not necessarily of intelligence, but of process, of a system that is complex, dynamic, and alive in a geological and perhaps a biological sense. We are listening to the symphony of a hidden world. To truly understand the potential of this hidden ocean, we must continue our descent to the very bottom. We sink through the dark water, leaving the icy ceiling far above. After what feels like an eternity, our senses detect a new presence, the sea floor. It is not a flat, silty plain. The seafloor of Europa is likely a rugged, rocky landscape, shaped by the same tidal forces that warm the ocean. There would be vast mountain ranges, deep trenches, and volcanic plains, all sculpted in eternal darkness. And it is here, at the boundary between rock and water, that the most exciting possibility exists. We are searching for hydrothermal vents. On Earth, in the deepest, darkest parts of our own oceans, where sunlight has never reached, life thrives. It clusters around hydrothermal vents, great fissures in the ocean floor, where superheated, mineral-rich water from the planet's interior erupts into the cold ocean. These are black smokers, spewing a dark plume of chemicals. And in this seemingly toxic environment, an entire ecosystem exists, completely independent of the sun. The base of this food chain is not photosynthesis, but chemosynthesis. Bacteria and archaea draw energy not from light, but from chemical reactions, metabolizing sulfur compounds and other minerals. These microbes then support a web of life, from tube worms with bright red plumes to blind white crabs and strange ghostly fish. Now transport this image to Europa. We drift towards a faint glow, not of light, but of heat. We approach a range of jagged undersea mountains, and from their peaks, we see it, a plume of dark, superheated water billowing into the cold blackness. It is a European hydrothermal vent. Here, at the bottom of this alien sea, is a potential oasis, a source of heat, a source of chemical energy, a source of nutrients. Everything that life needs to begin and to sustain itself, all in one place. The signals we are listening for might be strongest here. The chemical pulses from these vents, the seismic tremors of their activity, could create a rhythmic, information-rich environment. This is not just a geological feature. It is a cradle of possibility. It is the place where the line between a dead world and a living one might be drawn. We are floating before a potential genesis, a place where the encrypted message of Europa might not just be geological, but biological. As we linger near this hypothetical hydrothermal vent, let us contemplate the very nature of the signals we are searching for. The term encrypted signal can be misleading. It conjures images of complex mathematical codes, of an alien intelligence deliberately trying to communicate. While that is a tantalizing fantasy, the reality is likely something far more subtle and perhaps far more profound. The signals from Europa are not a language. They are a symptom of a complex and dynamic system. Think of a doctor listening to a human heart. The rhythmic beat, lub-dub, lub-dub, is a signal. It is not a message in words, but it is rich with information. A trained ear can detect the health of the entire organism from this simple, repetitive pattern. The signals from Europa could be analogous to this. The regular seismic rumbles caused by tidal flexing are the moon's heartbeat. The periodic chemical bursts from hydrothermal vents are its breath. The faint electromagnetic fluctuations caused by the saltwater ocean moving through Jupiter's magnetic field are its neural activity. The encryption is nature's own complexity. It is the challenge of separating the meaningful pattern from the background noise. Our instruments, like the magnetometer on the Galileo spacecraft, acted as our first stethoscope. It detected a peculiar magnetic field around Europa, one that could only be explained by the presence of a large body of conductive material, like a salty, liquid water ocean. This was the first signal that alerted us to the secret hidden beneath the ice. Future missions, like the Europa Clipper, will carry more advanced instruments. A radar that can penetrate the ice shell, a spectrometer to analyze the composition of water plumes, a more sensitive magnetometer to map the ocean's depth and salinity. These instruments are designed to listen more closely, to decipher the complex rhythms of this alien world. They are not looking for a greeting, but for a sign of life in its most fundamental form. The signal might be a consistent, complex chemical gradient around a vent, a pattern that could only be maintained by metabolic processes. Or it might be a faint organic molecule detected in an ice grain, ejected into space, a single word from an ocean's biological lexicon. The message is not, "We are here," but simply, "I am." And that, in itself, would be the most incredible message humanity has ever received. Let us allow our imagination to drift into the realm of pure speculation, guided by the principles of biology we know on Earth. If life does exist in this eternal night, what form might it take? We must abandon our terrestrial biases. There would be no trees, no grasses, no creatures with eyes, for there is no light to see. This would be a world shaped by pressure, darkness, and chemistry. At the base of the food chain, near the hydrothermal vents, we can envision vast mats of chemosynthetic bacteria. They might cover the rocks like a shimmering, living carpet, colored by the minerals they consume, perhaps reds, yellows, or deep purples. These microbial communities would form the foundation of everything. From there, life could diversify. Perhaps there are slug-like grazers, slowly moving across these bacterial mats, consuming the primary producers. They would be soft-bodied, built to withstand the immense pressure, with sensitive chemical receptors to navigate and find food in the dark. In the water column above, we might find filter feeders, creatures that resemble jellyfish or siphonophores, drifting lazily in the gentle currents, capturing particles of organic snow that rain down from the more active regions. They might move with a slow, rhythmic pulse, a gentle and hypnotic motion in the unending darkness. And where there are prey, there must be predators. Perhaps there are sleek, streamlined swimmers, more akin to fish or squid. Without eyes, they would hunt using other senses. They might detect the faint electrical fields of their prey, or use a form of sonar, emitting clicks and listening for the echoes. Imagine a school of these creatures communicating with patterns of bioluminescence, not for vision, but for signaling, to attract mates, to warn rivals, to coordinate a hunt. A silent, flashing conversation in the deep. This is the ultimate encrypted signal, life itself. The complex patterns of behavior, the intricate dance of predator and prey, the very chemical signature of metabolism, these are signals of a living system. We are not just listening for a sound. We are looking for a process. The ultimate discovery on Europa may not be a single creature, but the confirmation of an entire self-sustaining ecosystem, a second, independent genesis of life in our own solar system. And in that discovery, the silence of the cosmos would be broken forever. The concept of an encrypted signal also forces us to confront a profound philosophical question about ourselves. When we search for signals, what are we truly hoping to find? For centuries, we have scanned the skies with radio telescopes, listening for a structured, intelligent message. We have been searching for a reflection of ourselves, for another technological civilization capable of mathematics and radio engineering. This search is born of a deep-felt loneliness, a desire to know that we are not the only thinking beings in this vast, silent universe. But Europa offers a different possibility. The signal from its ocean, if it is biological, is not the product of intelligence or technology. It is the product of 4 billion years of slow, unthinking, persistent evolution. It is the quiet hum of a biosphere, not the deliberate broadcast of a civilization. And in some ways, this would be a more profound discovery. To find intelligent life would be to find another mind. But to find a second, independent origin of life would be to discover a universal principle. It would mean that the cosmos is not sterile, with one lucky exception. It would mean that life is a fundamental property of the universe, a natural outcome of chemistry and energy, given the right conditions. It would transform life from a miracle into a statistic. It would mean that wherever there is liquid water, energy, and organic molecules, life may be inevitable. The stars above would no longer be just beautiful, distant points of light. They would become a cosmic ocean of possibility, dotted with countless islands like Europa, each with its own hidden sea, each potentially humming with the quiet signal of life. The message from Europa, then, would not be for our minds, but for our spirit. It would not be an equation to solve, but a truth to absorb. It would tell us that we are not alone, not because someone else is thinking, but because the universe itself is alive. The pressure to be the sole custodians of consciousness would lift. We would simply be one beautiful, complex expression of a universe that is inherently, wonderfully, and ubiquitously fertile. And that is a message of comfort and connection, far deeper than any radio broadcast could ever be. Now let us turn our attention to the messenger, the robotic explorer designed to bring us closer to the truth. We are no longer speaking of imagination, but of engineering, of a real mission that is currently gliding through space. Its name is Europa Clipper. This is not a lander or a submarine. It is an orbiter, a scout. It is designed to be our ears and eyes, to perform dozens of close flybys of Europa, dipping in and out of Jupiter's dangerous radiation belts. Imagine this magnificent machine. Its vast solar arrays spread like wings, a suite of 9 advanced scientific instruments pointed at the icy moon. It is the most sophisticated probe ever sent to the outer solar system. One of its key instruments is a powerful ice-penetrating radar. As the Clipper swoops low over the surface, as close as 16 miles, this radar will send radio waves down into the ice. By listening to the echoes that bounce back, scientists will be able to map the thickness of the ice shell. They will be able to search for those pockets of trapped water, the subglacial lakes we imagined. They will, for the first time, measure the depth of the ocean and confirm its existence beyond any doubt. Another instrument, a thermal imager, will scan the surface for hot spots, places where the ice is thin or where plumes of water vapor may be erupting into space. If it finds a plume, other instruments, like mass spectrometers, will be able to fly through it and taste it. They can analyze the chemical composition of the water, searching for salts, minerals, and most tantalizingly, organic molecules, the building blocks of life. The Europa Clipper is a listener. Its magnetometer will listen to the magnetic signature of the ocean with far greater precision than Galileo could. Its gravity measurements will listen to the way the moon flexes and deforms under Jupiter's pull, revealing the ocean's properties. It is a mission designed to decode the natural signals of this world, to read its geological language. The data it sends back will not be a simple yes or no answer. It will be a rich, complex tapestry of information, a detailed portrait of an alien world that we will spend years, even decades, deciphering. It is the next logical step in our journey, moving from faint hints and speculation to hard, concrete data. The Europa Clipper is our emissary to this hidden sea, our hope for unraveling the beautiful enigma of Europa's encrypted song. Let us consider the medium through which these signals travel, the very substance of the European ocean, water, H2O. It is a molecule so common on Earth that we take it for granted. It flows from our taps, falls from our skies, and makes up more than half of our own bodies. But in the grand scheme of the cosmos, liquid water is a precious rarity. The universe is filled with water in its other forms, as tenuous vapor in interstellar clouds and as hard frozen ice in comets and on distant moons. To find it in its liquid state, stable for billions of years, is to find a potential paradise. The ocean of Europa is estimated to contain more than twice the amount of liquid water as all of Earth's oceans combined. Let that sink in. A moon smaller than our own holds the largest known ocean in our solar system. This is not a small subglacial lake. It is a true global ocean, but its properties would be very different from our own. The temperature would be just above freezing, a cold, dark environment. The pressure, as we've explored, would be extreme, and its chemistry would be alien. On Earth, our oceans are a sodium chloride solution, common table salt. The salts in Europa's ocean would be different, leached from a different kind of rock, under different conditions. Data suggests the presence of magnesium sulfates, Epsom salts, and perhaps chlorides, and carbonates as well. This chemical cocktail would affect the ocean's density, its freezing point, and its electrical conductivity. It is this conductivity that allows the ocean to interact with Jupiter's magnetic field, creating the very signal that first betrayed its existence. This chemical soup is also the potential broth of life. The interaction of this mineral-rich water with the rocky seafloor, especially at hydrothermal vents, creates a powerful chemical battery. It creates gradients, imbalances, and the potential for energy exchange. Life is, at its core, a process of harnessing energy from chemical imbalances. The very flavor of Europa's ocean, its unique blend of salts and minerals, is what makes it such a compelling candidate in the search for life. So when we speak of signals, we are also speaking of this medium. The water is the conductor of the seismic waves, the carrier of the chemical plumes, the memory of the moon's geological history. It is both the message and the messenger. To understand the ocean is to understand the soul of this distant, captivating world. Let's return to the surface for a moment and consider a spectacular possibility. Geysers, or more accurately, cryovolcanoes. Evidence from the Hubble Space Telescope and reanalyzed data from the Galileo probe suggests that Europa may be actively venting water from its subsurface ocean into space. Imagine standing on the icy plains and witnessing such an event. A fissure in the ice opens, and with a silent, explosive force, a towering plume of water vapor and ice crystals erupts from the moon, reaching hundreds of kilometers into the black sky. These plumes would be fleeting, transient events driven by pressure from below. But they are of monumental importance to our search. They are a natural sample delivery system. They are the ocean reaching out to us. If these plumes are real and consistent, a mission like the Europa Clipper wouldn't need to drill through miles of ice. It could simply fly through one of these plumes and collect a sample of the ocean directly. It would be like a bee gathering nectar from a flower, a gentle, non-invasive way to taste the secrets of the hidden world. The material in these plumes would freeze instantly in the vacuum of space, preserving a perfect snapshot of the ocean's chemistry at that moment. Spectrometers on the spacecraft could analyze the composition of these ice grains, searching for the telltale signatures of salts, minerals, and complex organic molecules. Finding simple organics, like amino acids, would be an incredible discovery. Finding more complex ones, like lipids or polymers, would be revolutionary. It would be the strongest evidence yet that the ocean is not just habitable, but potentially inhabited. These plumes are the most direct signal we could hope for. They are not encrypted. They are an open invitation, a message in a bottle thrown out into the cosmic sea, waiting for us to catch it. The search for these plumes will be one of the primary objectives of the Europa Clipper. Finding and sampling one would be a holy grail for astrobiology, potentially providing a definitive answer to the question of life on Europa within our lifetimes. It is a tantalizing prospect, a direct line of communication from a hidden ocean to our waiting instruments. We have talked about signals as rhythms and patterns, but let us contemplate the idea of the signal as a disturbance, an anomaly. In a perfectly stable system, things are predictable. But life is a force of disruption. It changes its environment. It creates things that shouldn't be there. One of the most powerful signals of life on Earth, visible from space, is the composition of our atmosphere. It is filled with oxygen, a highly reactive gas that, from a chemical standpoint, has no business being there in such high concentrations. It should have reacted with rocks and minerals and been removed long ago. The reason it persists is because of life. Photosynthetic organisms, like plants and cyanobacteria, are constantly pumping oxygen into the atmosphere. Our oxygen-rich air is a permanent, planetary-scale biosignature. It is a signal of a living world. On Europa, a similar signal might exist, not in an atmosphere, but in the ocean's chemistry. A living ecosystem, even a microbial one, would create chemical imbalances. It would consume certain molecules and excrete others, creating gradients and concentrations that pure geology cannot explain. Perhaps there are pockets of methane near a hydrothermal vent that are being continuously replenished at a rate that suggests a biological source. Perhaps there are unusual ratios of sulfur isotopes, a telltale sign that microbes are selectively processing them. These are the subtle, encrypted signals that astrobiologists will look for in the data returned from future missions. They are looking for a chemical anomaly, a disturbance in the force of equilibrium. Life does not like equilibrium. It thrives on imbalance. It is a constant, uphill battle against entropy. Finding evidence of such a battle in the dark ocean of Europa would be finding the fingerprint of life itself. The signal, then, is not a sound or a radio wave, but a chemical shout in an otherwise quiet chemical room. It is the persistent, undeniable evidence that something is happening in that ocean that is more than just geology. It is the signature of biology, rewriting the rules of its world. Let us zoom out again, leaving the specifics of Europa behind, and consider the context of its parent planet, Jupiter. Europa does not exist in a vacuum. It is locked in a complex gravitational and magnetic relationship with the largest planet in our solar system. This relationship is the very reason Europa is interesting. Jupiter is the source of the tidal forces, the constant gravitational squeezing and stretching that kneads Europa like dough. This tidal friction is the engine of all its geological activity. Without Jupiter's immense gravity, Europa would have frozen solid billions of years ago. It would be just another dead, inert ball of ice. Jupiter is its life support system, but Jupiter is also a source of immense danger. The planet is surrounded by a powerful magnetic field, which traps a donut-shaped region of intense radiation, containing charged particles from the sun and from its volcanic moon, Io. Europa orbits directly within this lethal radiation belt. The surface of Europa is constantly bombarded with a dose of radiation so high it would be fatal to a human in minutes. This radiation is a sterilizing force. It breaks down molecules, destroys complex organics, and makes the surface utterly inhospitable to life as we know it. This presents a paradox. The very planet that provides the heat to maintain a liquid ocean also creates a radiation environment that could destroy any life that reaches the surface. But this radiation could also be a creative force. When these high-energy particles strike the icy surface, they can trigger chemical reactions. They can break apart water molecules into hydrogen and oxygen. They can transform simple compounds into more complex ones, including oxidants. If these oxidants are then transported from the surface down into the ocean, through cracks or the slow churning of the ice shell, they could provide another powerful source of chemical energy for life in the ocean below. It would be a strange, indirect form of living off the light of Jupiter's radiation. The signal from Europa is therefore intrinsically linked to the symphony of the entire Jovian system. To understand the moon, we must understand the planet it orbits. They are partners in a cosmic dance of creation and destruction. A dance that has made a small, icy moon one of the most compelling places to search for life beyond Earth. Let's explore the structure of the ice shell itself more deeply. It is not just a simple, solid lid. It is a dynamic, complex world in its own right, a geological interface between the ocean and the vacuum of space. The theory of plate tectonics on Earth describes how our continents drift on a molten mantle. A similar, though distinct process may be happening on Europa, but with ice plates. The vast plains of ice may be behaving like tectonic plates, moving, colliding, and subducting. One plate of ice might be forced down under another, sinking slowly back into the warmer interior of the ice shell, where it eventually melts. This process, called ice subduction, could be a critical link between the surface and the ocean. It is a conveyor belt. As we discussed, the surface is constantly being altered by radiation from Jupiter, creating a host of interesting chemical compounds, including oxidants like oxygen and hydrogen peroxide. If the surface ice is then carried down into the ocean via subduction, it would deliver these powerful, energy-rich chemicals to the depths. This could provide the other half of the chemical equation needed for life. The hydrothermal vents on the seafloor would provide the reductants, things like hydrogen sulfide. The subducting ice from the surface would provide the oxidants. Mix them together in a liquid water ocean, and you have a planetary scale battery. You have a powerful engine for a potential biosphere, one that doesn't rely on sunlight or even solely on geothermal heat. The signal of this process would be written on the surface, the ridges, the cracks, the chaos terrain. These are the surface expressions of the dynamic ice shell. By mapping them, by understanding how the ice moves and cycles, we can understand the potential for this vital chemical exchange. The ice shell is not a barrier to life. It may be an essential part of the life support system. It is the bridge that connects the energy of the seafloor with the chemistry of the surface, making the entire ocean a far more dynamic and habitable place than we could have ever imagined. Now, we must address the sheer scale of time involved. The signals we are listening for, the processes we are describing, are not happening on a human timescale. Europa and its ocean have existed for over 4 billion years. For nearly the entire history of our solar system, this hidden sea has been churning in the darkness, warmed by the relentless pull of Jupiter. If life began there, it has had an immense amount of time to evolve and adapt to its unique environment. On Earth, it took billions of years for life to move beyond the microbial stage. For the vast majority of our planet's history, life was simple, single-celled, and invisible to the naked eye. It is only in the most recent chapter of Earth's story that complex, multicellular life has exploded in diversity. We should not expect to find intelligent, tool-using civilizations in Europa's ocean. The environment is likely too energy-poor for such a development. But 4 billion years is more than enough time for life to become complex, to form ecosystems, and to establish a firm foothold. It is enough time for evolution to explore countless strange and wonderful forms. The signal we receive may be a story 4 billion years in the making. The chemistry of the ocean is a record of its long interaction with the rocky core. The patterns in the ice are an archive of eons of tidal stress. If there are biological signals, they will be the product of an unbroken chain of life stretching back to the dawn of the solar system. This perspective is both humbling and calming. Our search is not a frantic race against time. The secrets of Europa have waited for billions of years. They can wait a little longer for us to develop the tools and the patience to listen correctly. When we send our probes, we are not just taking a snapshot of a distant world. We are opening a book whose first pages were written when our own planet was still a molten ball of rock. We are connecting with a history as old and as deep as our own, a parallel story of a world of water hidden under a blanket of ice. This sense of deep time allows for a more meditative, more peaceful approach to our exploration. We are not invaders. We are cosmic archaeologists, gently uncovering the past to understand our present and our place in the universe. Let's return to the idea of the signal as a form of music. Not music made by instruments, but the inherent music of physics and geology. Every celestial body has its own resonant frequency, its own unique hum. On Earth, we have the slow rhythm of the tides, the rumble of earthquakes, the hum of the atmosphere. On Europa, this music would be alien and profound. The dominant note would be the tidal frequency. Europa is tidally locked to Jupiter, meaning the same face is always pointed towards the gas giant. But its orbit is slightly elliptical, so the gravitational pull from Jupiter varies, rhythmically squeezing and relaxing the moon. This happens every 3.5 Earth days. This fundamental rhythm would drive everything. It would cause the cracks in the ice to open and close. It would trigger seismic events on the seafloor. It would cause the entire ocean to bulge and shift. This would be the bass note, the slow, steady heartbeat of Europa. Layered on top of this would be other sounds, the high-frequency crackle and pop of ice fracturing on the surface, triggered by thermal stress or meteoroid impacts. The deeper, more chaotic rumble of convection within the ice shell as warmer ice rises and cooler ice sinks. The percussive hiss of a hydrothermal vent, a constant, energetic sound on the ocean floor. And then there is the electromagnetic sound. As the salty ocean moves through Jupiter's magnetic field, it generates a faint electrical current, which in turn creates its own magnetic field. This field would fluctuate in perfect time with Europa's 3.5-day orbit. It is a pure, cinewave-like signal, a clear and beautiful note in the moon's symphony. To listen to Europa is to become a cosmic musician, an ethnomusicologist of the planets. We are trying to isolate each instrument to understand its part in the overall composition. We are trying to understand the harmony and the dissonance. The encrypted signal is the sheet music. It is a complex score that tells the story of the world's inner workings. And if there is biology, it will have added its own unique voice to this choir, a subtle, complex melody that we are only now beginning to learn how to hear. Let us consider the profound darkness one more time. On Earth, nearly all life is sustained, directly or indirectly, by the sun. It is the ultimate source of energy. This has shaped the evolution of life in fundamental ways, leading to vision, to circadian rhythms, to the very concept of day and night. Life on Europa would have no such anchor. It would be born of darkness and exist in darkness for its entire duration. How would this shape the nature of life? Without the day-night cycle, what would govern the rhythms of life? Perhaps the only clock would be the tidal clock, the 3.5-day cycle of Jupiter's pull. Biological processes, from metabolism to reproduction, might be synchronized to this slow, gentle rhythm. It would be a world without a morning or an evening, only the ebb and flow of gravitational energy. The absence of light also removes a major driver of diversity on Earth: visual appearance. On Earth, species develop bright colors to attract mates, camouflage to hide from predators, and intricate patterns for communication. In Europa's ocean, none of this would matter. Appearance would be irrelevant. Life would be shaped by other senses: touch, pressure, and above all, chemoreception, the ability to taste and smell the water. The world would be perceived as a landscape of chemical gradients, a symphony of dissolved molecules. Seeing would be tasting the plume of a distant hydrothermal vent, or sensing the faint trail of waste products left by a potential meal. This is a radically different way of experiencing reality. It is a world of deep feeling rather than bright vision. The encrypted signal in this context might be a chemical one, a complex molecule released into the water, not as a deliberate message, but as a biological byproduct that nonetheless carries information. A scent that signals the presence of a colony of bacteria, or a taste that warns of a predator's approach. To decipher these signals, we need to learn to think like a creature of the dark, to understand a world where the most important information is not seen, but felt and tasted in the subtle currents of an alien sea. Let us explore the human element of this search. The quest to understand Europa is not just about robots and data. It is a deeply human endeavor, driven by curiosity, wonder, and a yearning for connection. For decades, scientists, engineers, writers, and artists have been dreaming of this hidden ocean. It began as a fringe idea in science fiction and speculative science, a tantalizing what if. But with each new piece of data, from the first blurry Voyager images to the detailed maps from Galileo, the dream has slowly solidified into a tangible, scientific target. Think of the generations of people who have dedicated their careers to this. The physicists who modeled the tidal heating, the geologists who interpreted the strange cracks on the surface, the chemists who analyzed the faint spectral data, and the engineers who are now designing and building the spacecraft that will make the next great leap in our understanding. This is a multi-generational project, a scientific cathedral built over decades. Each person adds their own small piece, their own discovery, their own calculation, passing the torch to the next generation. It is a testament to what humanity can achieve when we are motivated by pure curiosity, by the desire to know what lies over the next hill, or in this case, under the next ocean of ice. The encrypted signal from Europa, in this sense, has already had a profound effect here on Earth. It has inspired countless students to pursue careers in science and engineering, It has sparked new avenues of research in fields from oceanography to microbiology. It has given us a shared goal, a grand adventure that transcends national borders and cultural divides. It is a story that reminds us of the best parts of our own nature, our relentless curiosity, our ingenuity, and our ability to dream of worlds beyond our own. The signal from Europa is not just a scientific puzzle, it is a source of inspiration, a cosmic mystery that calls to the explorer within all of us. As we drift in this imaginary ocean, let's consider the finality of a potential discovery. What if we found definitive proof of life? Not just ambiguous chemical signatures, but incontrovertible evidence of a living, thriving ecosystem. How would that change humanity? For one, it would likely be the greatest scientific discovery in human history. It would be a moment that recontextualizes our entire existence. Every religion, every philosophy, every culture is built upon a foundation of stories about our own origin, our own special place in the universe. The discovery of a second, independent genesis of life would challenge all of these stories. It would force us to see ourselves not as the center of creation, but as one branch on a much larger cosmic tree of life. This could be a profoundly unifying moment. The differences that we obsess over on Earth, our nationalities, our politics, our beliefs, would seem so small and insignificant in comparison to this shared cosmic truth. We would all become Earthlings in a much more meaningful way, united by our status as one of two known living worlds. It would also ignite a new golden age of exploration. The question would immediately shift from, is there life out there? To, what is it like? We would pour resources into developing the technology to go back to Europa, this time with a lander, a melting probe, and eventually an autonomous submarine. We would want to see this life, to study it, to understand its biochemistry, its genetics, its evolutionary history. It would be a new frontier, not of territory, but of knowledge, one that could keep humanity busy for centuries. The encrypted signal, once deciphered, would become a beacon, guiding us towards a future where we are no longer just inhabitants of Earth, but citizens of a living solar system. It is a beautiful, hopeful vision, a future where our understanding of life and of ourselves is immeasurably richer and more profound. But we must also consider the alternative. What if, after all our searching, we find nothing? What if the Europa Clipper and subsequent missions find that the ocean is sterile? What if the chemical signals are purely geological and the tantalizing environments around the hydrothermal vents are devoid of life? Would the journey have been a failure? Absolutely not. The search itself holds immense value. In our quest to find life on Europa, we will have learned so much more about the workings of our solar system. We will have pushed the boundaries of technology, developing new instruments and new methods of robotic exploration that can be used to explore other worlds. Most importantly, we will have learned more about the preciousness of life on our own planet. If we discover that an ocean twice the size of Earth's, filled with water, energy, and organic molecules, has remained lifeless for 4 billion years, it would underscore just how special, how rare, and perhaps how fragile life on Earth truly is. It would tell us that the spark of life is not as easy to ignite as we might have hoped. Our own planet would no longer seem like just one example of a common phenomenon. It would become a jewel of almost unimaginable rarity, a living oasis in a vast, sterile desert. This realization could inspire a deeper sense of stewardship and responsibility for our own world. We would be the custodians of the only known life in the solar system, perhaps even in this sector of the galaxy. The silence from Europa would become its own kind of signal. It would be a message of caution, a reminder to cherish the life that we have, to protect the only biosphere we know. So, whether we find life or not, the quest to understand Europa will ultimately lead us back to a deeper understanding of ourselves and our home. Either way, we win. Let's explore the idea of encryption from a different angle. Perhaps the message isn't hidden in complexity, but in simplicity, in the fundamental laws of physics and chemistry that govern both our world and Europa. Life, wherever it arises, must play by the same rules. It must harness energy. It must replicate itself. It must evolve. The language of life, then, is not English or binary code. It is the language of thermodynamics and information theory. The signal we are looking for is a signature of a system that is successfully fighting against entropy, the universal tendency towards disorder. A living cell is a marvel of order. It maintains a complex internal structure. It actively pumps molecules across its membrane. It stores information in its genetic code. This is a profound departure from the chaotic equilibrium of a non-living chemical soup. So, the search on Europa is a search for this signature of order. It might be found in the structure of a complex organic molecule. Non-biological processes tend to create a random assortment of molecules. Life, on the other hand, is highly selective. For example, life on Earth almost exclusively uses left-handed amino acids and right-handed sugars. Finding a similar non-random bias in the molecules from Europa's ocean would be a smoking gun for biology. This is what we mean by a signal. It is an unlikely arrangement, a pocket of order in a sea of chaos. It is a pattern so improbable that the easiest explanation is not complex geology, but the simple biology. The encryption in this case is the illusion of randomness that hides an underlying, life-driven purpose. To crack the code, we don't need a dictionary. We need to understand the fundamental principles that separate the living from the non-living. And in learning to read this universal language, we will be able to search for its signals, not just on Europa, but on any world we may one day visit. Let us consider the physical journey of a potential signal from the ocean to our instruments. It's a long and arduous path. Let's say a microscopic organism dies near a hydrothermal vent on the seafloor. Its organic molecules are released into the water. These molecules must then travel through the ocean, which could be up to 100 kilometers deep. They would be tossed by currents, potentially altered by chemical reactions, and diluted in a vast volume of water. Eventually, some of these molecules might reach the underside of the ice shell. From there, they would need to be incorporated into the ice. This could happen if water from the ocean freezes onto the bottom of the shell. Then begins the slow journey upwards. This single molecule is now trapped in an ice shell that is miles thick. it could be churned and mixed by the slow convection of the ice, a process that could take thousands or even millions of years. Finally, through some process, perhaps a cryovolcanic plume, or the slow but steady wearing away of the surface by micrometeoroids, this molecule is ejected into space. It is now a single frozen grain, adrift in the vacuum. It must survive the harsh radiation of Jupiter's magnetosphere. And then, at just the right moment, it must happen to pass through the path of our spacecraft, the Europa Clipper, and be captured by one of its instruments. The odds of any single molecule completing this journey are astronomically small, but the ocean contains an astronomical number of molecules. The plumes, if they exist, would eject trillions of tons of material over time. It is a numbers game. We are not looking for a single grain of sand on a beach. We are scooping up handfuls of sand, knowing that if the beach is made of the right stuff, we will eventually find what we are looking for. This perspective highlights the incredible sensitivity required of our instruments and the patience required of our scientists. The signal is faint, old, and has traveled a vast distance, but the fact that it might be there at all, waiting to be collected, is what makes the journey worthwhile. Let's revisit the lineal, those dark, reddish cracks that dominate Europa's surface. They are not just scars. They are a form of communication. They are the most visible evidence of the dynamic relationship between the ocean and the surface. For a long time, their color was a mystery. What is this dark, non-ice material? The leading hypothesis is that it is salt, specifically hydrated salts, that have been irradiated by Jupiter's magnetosphere. This is a crucial clue. It suggests that the water that wells up in these cracks is not pure, but briny, originating from the ocean below. The specific type of salt can tell us a lot about the ocean's chemistry. Recent studies using powerful telescopes have detected the signature of sodium chloride, table salt, in certain regions, particularly on the trailing hemisphere of the moon, the side that gets most heavily bombarded with sulfur from the moon Io. This suggests a complex chemical environment where different salts may be concentrated in different areas. These salty deposits are a direct signal from the ocean, brought to the surface and laid bare for our instruments to read. The Europa Clipper's mapping spectrometer will analyze the composition of these lines in unprecedented detail. It will be able to create a chemical map of the surface, identifying different types of salts, minerals, and hopefully organic compounds. We will be able to read the writing on the wall. We might find that certain types of chaos terrain are associated with specific chemical signatures, suggesting they formed over areas of the ocean with a particular composition. We might find that younger cracks have a different color than older ones, telling us how the material weathers over time. These lines are a frozen message, a letter from the deep. By learning to read the language of salts and spectra, we can begin to understand the properties of the hidden sea without ever having to touch it. Consider the role of chaos. We often think of order and pattern as the primary signals of life and complexity. But the regions of chaos terrain on Europa tell their own, equally important story. These are some of the most visually stunning and scientifically interesting features on the moon. Imagine a vast section of the ice sheet, the size of a large state, that has been shattered into a chaotic jumble of icebergs, plates, and ridges. These icebergs have clearly moved, rotated, and been refrozen into a new, disorganized matrix. What could cause such a massive disruption? The most likely explanation is that a large plume of warm ice, or perhaps even a pocket of liquid water, rose from the deep and melted the ice shell from below. This would create a vast, temporary subglacial lake just beneath the surface. The solid ice crust above this lake would become brittle and unstable, eventually collapsing under its own weight into the slushy water below. The ice rafts would then drift around for a time before the area refroze. This process is a powerful mechanism for exchange between the ocean and the surface. The collapse would bring surface material with all its radiation-processed oxidants crashing down into the melt water. And the water itself, originating from the deep, would be rich in minerals and salts from the ocean. These chaos terrains are giant mixing bowls, places where the ingredients for life are brought together in a dynamic, energetic environment. They're also among the youngest features on Europa, suggesting that this is an ongoing process. The signal from the chaos terrain is a signal of heat, of dynamism, and of exchange. They are signs that Europa is not a static, frozen world, but a geologically active one. They point to places where the barrier between the two worlds, the surface and the sea, is at its thinnest, and they will be prime targets for future lander missions, the most likely places to drill to find the shortest and easiest path to the water below. Let us think about our own planet as an analogy. If an alien spacecraft were to fly by Earth, what signals of life would it detect? It would see the oxygen in our atmosphere. It would see the spectral signature of chlorophyll in our forests and jungles, the red edge. At night, it would see the artificial lights of our cities, and if it listened on radio frequencies, it would hear a cacophony of our broadcasts. Now imagine if Earth were shrouded in a thick, impenetrable cloud layer, like Venus. The search would become much harder. The aliens would have to rely on more subtle clues, like the chemical composition of the upper atmosphere. Now take it one step further, and imagine Earth's entire ocean was hidden beneath a 10-mile thick shell of ice. All of the most obvious biosignatures would be hidden. There would be no atmospheric oxygen, no city lights, no radio chatter. The search for life would have to become incredibly subtle and sophisticated. This is the challenge we face at Europa. We are searching for life on a world that has been hermetically sealed. The signals are not broadcast for all to see. They are faint whispers that have to leak out through tiny cracks. This is why the search is so focused on things like magnetometry, radar sounding, and trace chemical analysis in plumes. We are forced to use the most sensitive, indirect detection methods possible. It requires a level of scientific detective work that is unprecedented in the history of exploration. It forces us to be clever, to be patient, and to look for clues in the most unlikely of places. The encrypted nature of the signal is not a deliberate act of concealment by an alien intelligence. It is a natural consequence of Europa's geology. The planet is shy. It holds its secrets close. And this shyness, this subtlety, is what makes the search so challenging and the potential discovery so incredibly rewarding. It is a puzzle of the highest order, a cosmic locked room mystery. Let's imagine the final phase of our journey. We have listened, we have analyzed, we have gathered our clues. It is time to ascend. We leave the hypothetical hydrothermal vents and the dark seafloor behind. We rise through the immense column of water, the pressure slowly decreasing. The distant, muffled thunder of the ice shell above us grows slightly louder. We see the underside of the great ice ceiling, a rugged, inverted landscape of frozen peaks and valleys. We phase through it once more, this time rising towards the light. The journey through the ice is a journey back into the known. The absolute blackness gives way to a deep, penetrating blue, which slowly brightens as we near the surface. The groaning of the ice becomes more distinct. After traveling through miles of solid ice, we breach the surface. We are back in the silent vacuum, under the stark light of the distant sun. Europa lays before us again, a cracked, white sphere. But it looks different now. It is no longer just a beautiful, mysterious object. We know what it hides. We have a sense of the immense, dark, dynamic world that lies just beneath our feet. The cracks are no longer just patterns. They are conduits. The chaos terrains are not just scars. They are windows. The faint magnetic field is not just a physical anomaly. It is a heartbeat. We look up, and Jupiter hangs in the sky, a silent, powerful guardian, the cause of all this hidden wonder. We have not found a definitive answer, not yet. But we have explored the possibilities. We have mapped the mystery. We have listened to the silence and heard a potential song. The encrypted signal is still encrypted, but we have begun to understand the language in which it is written. It is the language of geology, of chemistry, of physics, and perhaps of biology. Our journey is ending, but the true human journey to Europa is just beginning. Let's ponder the name itself. Europa. In Greek mythology, Europa was a Phoenician princess who was abducted by Zeus in the form of a magnificent white bull. He carried her across the sea to the island of Crete. It is a story of a journey across water to a new world, a new beginning. It is a fitting name for this moon. It too is a world defined by its journey, orbiting its own powerful, thundering god, Jupiter. And it too promises a new world, hidden across a cosmic sea, beneath a surface as white as Zeus's bull. The myths we tell often echo the truths we later discover. We have always been drawn to the water, to the unknown depths. We have always imagined monsters and wonders lurking in the abyss. The ocean of Europa is the modern embodiment of this ancient fascination. It is the ultimate abyss, the darkest and most unknown sea we have ever contemplated. The signals we seek are the modern equivalent of the siren's song, a mysterious call from a place we cannot see, promising a revelation. Our desire to explore Europa is not just a scientific impulse, it is a mythological one. It is woven into the very fabric of our storytelling nature. We are explorers. We are questioners. We are dreamers. We look at a cracked, icy moon, and we do not just see ice. We see an ocean. We see the possibility of life. We see a reflection of our own deepest held hopes and fears about our place in the cosmos. The journey to Europa is more than a mission. It is a pilgrimage. It is a quest to answer a question that has haunted us since we first looked up at the night sky. Are we alone? Europa, named for a princess who crossed the sea, might just be the one to finally give us our answer. Let's consider the future, beyond the Europa Clipper. What comes next? The Clipper is a reconnaissance mission. It will map the territory and identify the most promising targets. The next logical step would be a lander. Imagine a spacecraft that doesn't just fly by, but touches down on that icy surface. It would have to be heavily shielded to survive the radiation, and it would need a power source, likely nuclear, to operate in the cold and dark. Its primary mission would be to sample the surface ice directly. It could carry a small drill to access the ice just below the surface, which is more protected from radiation and more likely to contain pristine material from the ocean. It would have a sophisticated on-board laboratory to analyze the samples for organic molecules, for signs of microscopic life, and to determine the precise chemical composition of the non-ice materials. A lander could give us our first ground truth, confirming what the orbiter can only see from a distance. But the ultimate dream is a cryobot, a melting probe, a nuclear-powered probe that would land on the surface and then slowly melt its way down through the entire 10 to 15 mile thick ice shell. This is a monumental engineering challenge. The probe would have to navigate through the ice, avoiding obstacles and maintain communication with the surface. The journey could take years. But at the end of that journey lies the greatest prize in all of solar system exploration. The moment the cryobot breaks through the ice and deploys a small, autonomous submarine, a hydrobot, into the liquid water of Europa's ocean. This would be a moment akin to the first steps on the moon. For the first time, we would have a presence inside an alien ocean. The hydrobot could swim, carrying cameras, lights, and chemical sensors. It could explore the underside of the ice, search for hydrothermal vents, and give us our first glimpse of the world hidden below. This is the long-term vision. It may take 50 years or 100, but it is the dream that drives the current missions. The faint, encrypted signals we are detecting now are the first breadcrumbs on a long trail that could one day lead us to swimming, seeing, and listening from within the heart of Europa's cosmic sea. As we conclude our meditative journey, let's reflect on the color of Europa. We see it as white with reddish-brown streaks. But these are the colors of the surface, the colors of radiation-burned salts and ice. The true color of Europa is black, the profound, absolute black of its hidden ocean. It is a world of darkness, and yet there may be another color, the color of life itself, bioluminescence. On Earth, in the deep ocean where sunlight cannot reach, life has learned to make its own light. From the flashing lures of anglerfish to the shimmering clouds of bacteria, the deep sea is filled with cold, living light. It is used to attract prey, to find mates, to startle predators. It is a language spoken in photons. If life exists in Europa's ocean, it is almost certain that it would have evolved this ability. In a world of total darkness, the ability to create even the faintest glimmer of light would be a powerful evolutionary advantage. Imagine our future submarine, the hydrobot, turning off its own lights for a moment. It floats in the absolute black, its sensors listening, and then it sees it. A faint blue-green pulse in the distance, then another. A whole field of gentle, glowing organisms, perhaps anchored to a hydrothermal vent, or a sleek, dark predator that suddenly illuminates its body in a brilliant, terrifying flash. The visual signal, the one signal we thought we could never receive from this dark world. This would be the most unambiguous confirmation of all. Not a chemical squiggle on a graph, not a subtle magnetic fluctuation, but light. A beacon of life, shining in the eternal night of a hidden sea. This is the ultimate dream of the Europa mission. That one day, we will not only hear the encrypted signals from this distant ocean, but that we will see its silent, secret, and beautiful light. The darkness of Europa may be hiding the most brilliant discovery of all. Our long, peaceful journey is now coming to a close. We have traveled hundreds of millions of miles, descended through a crushing shell of ice, and drifted in the dark, silent waters of an alien sea. We have listened for its heartbeat in the tidal flexes, searched for its breath in the plumes of hydrothermal vents, and imagined the strange and beautiful life that might swim in its eternal night. We have learned that the encrypted signals from Europa are not a deliberate message, but the very pulse of a living, breathing world. It is the complex rhythm of geology and chemistry and perhaps the quiet, persistent hum of biology. The secrets of Europa are deep, and we have only just begun to listen. But the very existence of this hidden ocean, this second great ocean in our solar system, has already changed our perspective. It has shown us that the potential for life, for worlds of water and wonder, can be found in the most unexpected places. It gives us hope that the silent cosmos around us is not empty, but is filled with secrets waiting to be uncovered. As you drift now on the edge of sleep, hold on to that sense of wonder. Let the immense, quiet mystery of Europa's ocean be a source of peace. Know that while you rest, our robotic explorers continue their patient watch, and here on Earth, dreamers and scientists continue to listen, hoping one day to fully decipher the beautiful, encrypted song of this distant, icy moon. Thank you for joining me on this journey. If this cosmic story helped you relax and find a moment of peace, please consider liking this video and subscribing for more lectures for sleep. What do you imagine is making these signals in Europa's deep ocean? Let us know your dreams and theories in the comments below. Sleep well, and may your dreams be filled with cosmic wonder.